Hello guys, welcome back. Today we are starting our second lesson, our designing foundations. Today we are going to learn about Hansen's burning capacity equations. As you can see, it has something different: C, NSC, SSC, DSC, ISC, GSC, BSC, and another things. For soils with theta more than 0 and for soils theta is equal to 0. In that equation, S is shape factor, D is depth factor, I is inclination factor, G is ground factor, B is base factor. These things in Hansen and Vesic equations are really similar, and you don't need to learn them very well because in any project, the engineer on the site and the company that gonna give you this data from the site gave you the QU, and you don't need them, but if you know them, it's good for you and your job, and you can be a great engineer. Okay, for that we must check Hmax. It always this check is right. Then don't do it. Okay, let's see how to calculate them. NC and NQ are like Meyerhof, and as you can see, the equations are here, but N lambda is different. Then we have shape factors and depth factors, and also we have K and the load factors here, I, load factors, if I don't make any mistakes, load factor, and here ground factor, and last factor. As I said, base factor. It always, many of them are equal to 1, but we must know how to calculate them. Okay, in the Vesic, everything is like like Hansen, but we have some differences. For example, in N lambda and shape factors, and here are inclination factors and ground factors and base factors. I give you this note so you can have these numbers, so don't worry. But in the end, which relationship we should use and where? Full scale foundation tests to find accurate load bearing capacity theories have been very expensive so far, and only loading tests show that none of the methods and theoretical comparison tests so far have a signal advantage in terms of load bearing capacity over other methods. But I tell you something, Terzaghi in many occasions fail to give us a good number. Because of that, in many occasions we delete the Terzaghi numbers. Terzaghi is never the first equation to have been widely used due to the ease of use. It's easy to calculate. These calculations are still used for vertical loads on enclosed surface. Meyerhof and Hansen relationship are widely used based on observation and review. Okay, we use Terzaghi for cohesive soils where D to B is lower than 1, and for the quick estimation of Q ultra. It's for quick estimation, not for the real number. Comparison with other methods for foundation with horizontal anchors and horizontal forces. It don't depend the factors that we when we have load like this, let's say it's load, it's not good to use Terzaghi because it can't predict it well. Equation Meyerhof and Hansen-Vesic can be used in any situation. Hansen and Vesic when the foundation is curved and the foundation in a slope surface. It is recommended that the least two practical methods to use so that are the result of two methods are consistent. Use the first method. Use computer method to speed us the process. Okay, let me give you some example of this. For example, let's think we have, let me make it. Let's think we have the 4 factors. For example, Terzaghi, Meyerhof, Hansen, and Vesic. And we want to know the real capacity. Okay, and here is Q alt. The first one, Q alt is equal to Q alt. Okay, the first one turns out is give us 2, 3, 2, 3. We just the Q ultimate is equal to, we just easily say 2 equal to plus 2 plus 3, 4. Or we can use another things, for example, give them 2 plus, for example, 3, something like this. But I prefer that this kind of equation is good. Let me delete that. And the answer is gonna be this number that I put here. Okay, let's see if we have, turns out 1, 4, 5, 6. Then Q alt is equal to 1 plus 4, 5, 6. No, it's not right. You know why? Because the 1 is the wrong number. Wrong. It's because maybe the load is different or something else. And the answer is gonna be 3, 4, 5, 6. And as we sum them, 9, 15, and it's 5. The answer is 5. Okay, for your next lesson, just solve these two equations. 35, 26, 37, 29. And this one, 18, 30, 19, 21. These two, x and y. Find them for your next lesson. Have a good time.